Hello everyone, and welcome to episode 6 of the Besiege Bots tutorials. Today, we will be learning easy ways to build a horizontal or vertical spinner system, including the spinner itself, as well as the motor and the weapon mount. Before we get to building the spinners, let's first take a look at the functioning principles of Besiege Bots motors. There are two main types of motors we tend to use in Besiege Bots: torqueless motors and direct drive motors. First, let's take a look at an example of a torqueless motor. As the name suggests, a torqueless motor does not transfer torque to the chassis of a robot whatsoever. And the way it achieves that is by making the spinner free spinning relative to the chassis. As you can see, the spinner, which is the yellow color section, is attached to the starting block, which represents the chassis, with a free spinning connection. We tend to use spin blocks for that because it's both free rotating and very strong. Then we have the motor, colored purple and attached to the spinner. This is the motor that will cause the spinner to spin, but we still have a very important part, the braces. If we delete the braces and spin the motor, we can see the spinner barely spins because the motor has nothing to push against, so to say. This is where braces come in. They generate a lot of rotational drag, which helps prevent the motor from spinning too fast, thus being able to transfer all the torque into the spinner itself. In conclusion, a torqueless motor uses braces to anchor the motor, which then spins a spinner that is freely rotating. The main advantages of torqueless is that they are easy to build and usually very reliable. But because the braces don't fully stop the motor, only slow it down, some of that RPM is always lost spinning the motor, which means spinners that use torqueless doesn't hit as hard. For hitting more hard, we will have to take a look at direct drive spinners. This type of design, as the name suggests, directly drives a spinner with the motor. And the motor doesn't move because it's solidly connected to the chassis. As you can see here, it leads to greater RPM and thus a harder hitting spinner. However, this design also has drawbacks. The first one being that now the torque generated by the spin-up and the drag from continuous rotation of the spinner all gets fed back into the chassis, which leads to the robot driving much less well or not at all. To alleviate some of this problem, we can install a counter-reaction wheel system, which is painted green here. This is another motor attached to the chassis, and attached to it are just braces. And since braces generate a lot of angular drag, you can have this motor rotate the opposite direction of the spinner, and cancel out the torque of the spinner. If we spawn in right now, and we spin up both the spinner and the counter-reaction wheel, you can see the chassis part does not spin. But if we remove the braces on the counter-reaction wheel, now when we spin up, you can see all the torque is being put into the chassis and the chassis is spinning. This is why a counter-reaction wheel is very, very important on direct drive spinners. Another disadvantage of direct drive is that they are much more difficult to make durable. Because the motor is driving the spinner directly connecting to the chassis, it is going to experience all the load when the spinner hits something. Which means the motor usually breaks on hits if we don't build an extra reinforcement, which is much more advanced and complicated. And it is for this reason the spinners we will be building today will be torqueless, since they are much more simple to get working. We will talk about building more advanced motors in an upcoming video. The first spinner we will be building will be mounted from just one side, so it's better for things like undercutters and overhead horizontals. Let's start by building the mount and the motor first. The motor we will be using is commonly called a Fruitloop motor. It was invented by Turbo in 2019 and takes the name from the bot it was first mounted on, called Fruit of the Tomb. To start, we will build this motor facing up, which means the spin block, which is the mounting point, will be under the spinner, which is good for things like overhead spinners, but you can always flip it over for undercutters. To start, we place a spin block with the connector facing up. Once we are done, this will be the mount. We then move the starting block out of the way. Then, we place a large unpowered wheel with its connector also facing up. This means the green add point on the large wheel will face downwards. We then place a medium powered wheel on the center add point of the large unpowered wheel, and place braces onto the wheel. Make sure the braces only connect to the wheel on one side. Then, we rotate the medium wheel plus the braces 180 degrees so it's clipped inside the large unpowered wheel. Because the medium wheel is connected to the large unpowered, it will ignore the clipping and the large wheel will protect the medium wheel. And that is the motor assembly done. We then have to mate it to the mount spin block, so we just move the whole assembly down until the spin block connector is touching the unpowered wheel add point. But make sure it's not touching anything else it can connect to. We then set the spin block to free spinning by turning the acceleration to 0 and turning off limit speed to motor. And now we have the mount and motor all finished. To connect this mount to the chassis, you just have to connect the spin block to the chassis using wood blocks. Now we can build a spinner for it. Just for demonstration, we will build a simple spinner. We can start by attaching a wooden panel to the large unpowered wheel, since wooden panels are very stiff as they parent to the large unpowered wheel. And then we can attach some grabbers to it. We can then mirror it to the other side as well, and we have ourselves a spinner. Now, we have to measure the spinner diameter to determine how fast the motor can spin, and that's pretty easy. We place down a row of wood blocks on top of the spinner. We can pin it. We can then get a rough estimate of the spinner length to set the speed for now. Compared to the wood block bar, it looks like it's just under 13 blocks in diameter. And now we can check the spinner speed section of the rule set and see what we can set our motors to. It seems we can set our motor to 5.5 speed. However, the rules do specify the spinner when spun up has to stay under the diameter you have set the speed to. So we have to check that. We can spawn in with the wood blocks pinned and we can spin up. And we see that we did not expand over diameter. So this speed is the way to go. And here we have it. We have ourselves a weapon that will work well on horizontal spinners. Next up, let's make a torqueless motor setup more suited for vertical spinners. Most common vertical spinners will have 2 weapon supports, so let's make a weapon system that's mounted on both sides. This time, we will start with the core of the spinner, which will be a log. To mount the spinner to the chassis, we will use something we call an F6 mount, invented by Dunn in 2018, named after his robot F6. The F6 mount involves clipping freely rotating spin blocks inside a log, and they act as bearings. Let's build just one side of this on the log first. First, we place a spin block on the log. Then, we rotate it 180 degrees horizontally, so that it is inside the log. Then, we rotate it 45 degrees axially. Now, you can see the corners of the spin block now stick out of the log and thus can be reliably connected to without worrying of connecting to the log. We can then place down a wood block that's supposed to connect to the spin block, and move it out so the connector is only barely touching the spin block, which will give the log the room to spin. The wood block can then connect to the chassis. Because the spin block sticks out in 4 places, we can of course use more wood blocks if needed. And that is the mount assembly done. We can then build the motor. The motor is very simple. We just place a motor of choice on the end of the log. Then, we move the motor out by very small steps until the connector can only connect to the log and never the spin block. The log is a little longer in this configuration, and you want the motor to spin the log only and never the mount. Then, we attach braces to the motor, and we are done with the sides. For the other side, we can simply mirror over all the blocks over the center of the log. And here we have it, a dual-side mounted motor that will work well for vertical spinners. The process of building the spinner itself is the same as the horizontal. Use whatever materials that you think would work best for your spinner. And then we use the wood blocks to measure the length. We then set the motor speeds and measure again with the spinner spun up. And we can see again, the spinner does not expand over the diameter limit of that specific motor speed. So it is now legal for competition. And here we have it, a double F6 mounted spinner running off of torqueless motors that will work well for a vertical spinner. And that is it for today. Thank you for watching.